section 2.1 today, and we're going to start with symbols and terminology. And as we're taking a look at this, let me just in advance going to tell you, this is not going to look like an algebra course or a trig course. This isn't geometry. We're going to cover a lot of things that you've probably never seen before. And we may hit on a few things along the way that you have, and that's great too. But in general, this is not going to be what you've maybe typically experienced in a math course. For better or for worse, that's what this course is, okay? So I hope that you will enjoy it because it is a little different. So the first thing we're going to talk about is what a set is. So a set is simply a collection of objects. So for example, those can be physical objects, okay? Collection of books. That's okay, we can do that. But it can also be something like the people in my family. Okay? Now, elements are the individual objects that are inside of a set. Okay, so these are the objects belonging. To a set. Okay, so if we were to use the same above example, the people in my family, and I'm talking, my nuclear immediate family, I can say myself, right? So there's my name. I can say my husband's name is Jeff. My daughter's Abby. And my son is Eli. They would be the elements in the set people in my family. Okay, so that's an example of a set. There are several ways of writing. All right, that was interesting. All right, there are several ways to describe sets, notations that can be used. One way is a word description, so you can flat out just write out, like I did on the first example, the people in my family. That is one description, okay? That's one way of doing it. So let me write that one since I just said it. You know what? I'm going to write a different one. I have it written down here. We'll do this one so that it'll translate into the next one. We can say all whole numbers less than 7. Now we'll talk a little bit more later about whole numbers, but let me just for the moment. Believe it or not, my screen says more. There it is. Okay. Let me just remind you again right now what a whole number is. A whole number is starting at 0 and counting up. So 0, 1, 2, 3, 4. Those are whole numbers. Okay, we'll talk more about the numbers later. But there's also something called set builder notation. And in relation to this, sometimes it just kind of feels awkward. So there's two ways of doing set builder notation for this description. The first thing is set builder notation starts with these curly braces. It's going to have an X or a variable. We usually use X. And it's going to have a vertical line next to it. Okay? This is read all X such that. Okay, so the X there and then in that line is read as like it says such that. And one way we could do this is we could write the exact verbal description that I just did on the first part. So I could say X is a whole number less than 7. And it ends in a curly brace. That isn't a very good example of a curly brace. Let's try that again. That's better. Okay, so that's one way to do it. It's perfectly legit. There's nothing wrong with that. But there's another option that might be a little bit more convenient because it's shorter. We can also write it this way. We can do the X and then the such that. That's there for real always. But we could also just say X, we can use the less than symbol, and 7. Now we have to be careful though, because that's not exactly what I already wrote. What number could that mean? If I just say x is less than 7, what could that mean? It could be do you say 3.25? Yeah, it could be 3.25. It could be -8, right? So we need to clarify what kind of number this has to be as well, because this is still a little bit too generic for what I really mean. So we're going to also say x is a whole number. And we will learn one more notation for that later, for how to say it's a whole number without writing it, but we're not there quite yet. Listing method is a very popular one when it's possible to list things. So the listing method is to simply list the numbers we're talking about in this case. So what number did we start with? 0, right? Whole numbers start with 0. We mentioned that earlier. So I can write down the number 0. And then what else do I write? So tell me the numbers I'm going to write down. All the way through 7? Actually, I'll stop at 6 on this one. So I'm going to write down all the numbers. You actually physically write them down. We don't put the little ... ellipse in the middle. We're going to really write them all out. And that should sort of trigger in your mind that, okay, that was great because I only had to write numbers 0 through 6 and there was no real need to put the ... in the middle. But as you can imagine, if this said that they wanted you to do the listing method and the whole numbers that are less than 50, it doesn't sound like a lot of fun. I don't want to write down the numbers 0 through 50, right? So this has limitations. I mean, it's very clean and easy when the numbers are smaller, when the elements are a small set. So, all right, the unique set the null set, which is unique. So this is interesting. This would be something like a set that has nothing in it. You might be thinking, well, why would I need that? So let me give you an example. First, let me tell you the notation. The notation for this set is, there's two notations. One is a 0 with a slash through it. You've probably seen this notation before. This is not the number 0. Please, please do not write your zeros with a slash through it, because this notation has another meaning. This notation means, for what we're working in, that it's the null or the empty set. What other use have you seen this notation for? Do you remember?
No solution.
No solution, yeah. You see this used for no solution. Sometimes you see it used in like an algebra course when you're looking where two lines intersect, and they don't. They're parallel. And the answer is there is no solution. Okay, so this is not the number 0. That's the first issue. The other way, there's one other way to write this. Remember the curly braces a minute ago? So this is really exciting. You can write curly braces and just put nothing in them. That's a legit way of writing this, okay? Here's what you can't do. You can't write the curly braces and then put the 0 with a slash through inside of it. This is a big no-no. That means something different. Okay, so don't combine those two notations. Pick one or pick the other. All right? And know what they mean in case they're used for you instead. All right, let me give you an example of how this would be useful, I guess, or how you could describe it. So what we said is that this is the set with no elements. So let me describe a set with no elements with context. So let me give you an example. An example could be something like this. This is the set of teenagers. Living at my house. I can talk about that set of teenagers all I want. They're perfect. They clean their rooms. They never make a mess. They eat all their dinner and they clean up after themselves. And that's all well and good, but the reality is I'm describing something that has nobody in the set, right? There are no teenagers living in my house, so I can talk to you all day about how wonderful they are, but they don't exist. Okay, so it has practical purpose. We can still talk about something and it not actually happen. So this is a set that would have nothing in it. All right, so let's take an example. We're told on this one to list the elements of each set using the set notation. Okay, so that's the curly braces with the X and the bar. That's set notation. And the listing method, whereas we list out all the items inside of the curly braces. Both of those use curly braces. So this is a verbal description or a word description. It says the set of all whole numbers greater than 8 and less than 18. So we're going to do these in order. It first told us that we're going to use the set notation, right? So we're going to do set notation. We're going to start with a curly brace and an X and a such that. If you can't do anything else, this is where you start, right? Because it's always like this for set notation. You can write out, if you so desire, all whole numbers greater than 8, less than 18. If you really, really want to, you can do that. That's okay. But it's kind of messy looking. I mean, it doesn't really look very much like math, I guess, maybe, or something like that. And it's really more wordy than you need. We can condense that, right? Kind of like we did with the x less than 7 a minute ago with the notation. So we can do the same thing here. We can write an 8. So it says it's greater than 8, so we can write an 8. We can do a less than sign and put an x. That's greater than 8, right? That's what that says. 8 is less than x. It means x is greater than 8. And I can do another less than sign and put the 18. And I can, oops, before I do that, one more thing to do. So this would be all the numbers between 8 and 18, but then we're going to have the same problem that you mentioned before, right? This is all the numbers between 8 and 18. So it would include 8.7. And that's not what this described. This said the whole numbers, right? So we also need to say x is a whole number. And curly brace in that. So that's my set notation. Some books will call this set builder notation as well, just in case you've seen that notation or phrase used before. Here's our listing method. So the listing method is a favorite as long as it's not too long of a list, at least as far as I'm concerned. What number is the first one I'm going to list? 9. And what's the last number I'm going to list? 17. And that's my listing method. We have one more example of this variety. So this one says to list all the elements of the set, use set notation and listing method. Same directions, right? Okay. But this one almost looks like they already wrote down the listing method. What is not right about this being the listing method? The dot, dot, dot. So the listing method is not the dot, dot, dot part in between. The listing method really means to write them all out. So we are going to have to actually write them all out. It's not already given in one of those forms. So we're going to start again with the set notation. Now, there's several ways that we could do this set notation, but it all starts out like this. Curly brace, X bar. Okay? So tell me, how would you describe those numbers in this example?
Greater than 1, less than 23.
You could do that. And what else about them? They're even. Okay? So one way to describe it, I'm going to use the one that she gave, is that we can say it like this. Right? That they're between 1 and 23. And someone else said that they're even. Did anyone else think of a different way in particular to do this? Yeah.
X is greater than or equal to 2.
Mm-hmm.
Is less than or equal to 22. X is whole, X is even.
Yes, and we can avoid the whole part because even automatically implies that it's whole. So we can actually not have to write that one. So we could use the less than or equal to symbols right there instead. Either one's fine. If you really wanted to get creative, you could say something like, instead of the 1 and the 23, you could say 1.86, right? It would still work, right? Instead of using the 23, you could use 22.94. It would be okay. I mean, it isn't natural, but that's okay. All right, so let's use, hang on just a second. Let's use the same set, and we're going to do the listing method. Okay, sorry, I made my pen a little bit broader. I think it might work better. Listing method. So in the listing method, it's going to look an awful lot like it did before, except it won't have all the dots, right? So I'm going to do 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 22. And that's the listing method. Okay, we'll do one more, and that will bring us to a really nice place to stop. We're going to describe a set using set builder notation, using x as the variable. All right, so this says the set of all rational numbers. Now, we're going to talk next time about sets of numbers. If you look at the second page, it's got several things listed out there. But let me talk first about the set notation. So just as we did before, this is x such that, and you see now, notice it said set builder this time, right? I told you that it's going to go back and forth a little bit, even in what I'm going to be doing. So we've got the x such that. So one way to do this is to write x is a rational number. And I'll talk about rational numbers next time. But let me actually have you put in one more notation in here. And we'll talk about these notations next time too. Another way to write this is to write an x. We're going to put a symbol that you've never seen before, perhaps. It looks kind of like an E. Okay. And we're going to put a Q with an extra line on the left-hand side. And I'm going to say that that also means x is a rational number. So I'm going to talk more about that notation next time when we talk about the different numbering systems on your second page of your notes. But while you may not look at that and say, well, I understand what that meant, it was certainly shorter to write, wasn't it? And there's some nice benefits to some symbols in mathematics, and that's what we're going to be looking at. So